there is a second chapter on networking now, explaining the different network drivers that we have at our disposal. So there is the default driver. The default model is the bridge driver, and then there is none, host, and container. So the default bridge, that's what we get if we just like Docker run a container. In that case, the container gets a virtual Ethernet interface, and that interface is connected to a switch on the Docker host. So if I, for instance, I Docker run an Ubuntu container, and then I try to execute ifconfig. Now, let's take another image. Let's use Alpine, because I think Alpine has ifconfig. Yes. If I use ifconfig, I see I have ETH0, I have hello, and this ETH0 interface is connected to a kind of symmetrical virtual interface on the host, and I can see that on the host with ifconfig. We can see like those VETH, etc., etc. All these are the other pair, the other half of the container virtual interfaces. And then all these interfaces are connected together. So if I want to show that, I have to install bridge utils and then do brctl show. And this tells me that I have a bridge or a switch, it's the same thing, called Docker 0. And in that bridge, I have all these interfaces. So you can imagine that there is a virtual Ethernet switch in the machine, and all the containers are connected to that. So that's the default model. And then the containers get IP addresses on that. Yeah?
Sorry, can you go back one?
Sure.
So spanning tree enabled, I'm assuming that's what STP enabled is?
Right, so what is about this STP thing? So this is using the Linux bridge code, and the Linux bridge code can be used to implement like spanning tree, but in that case it's disabled because there is only one bridge, there is only one internal bridge. It has no link going outside, so there is no like spanning tree wouldn't make a point. But yeah, that's why it shows that. Yeah.
So I don't have to worry about
You don't have
thousands of spanning tree updates and things like that.
No, you don't have to worry about spanning tree updates. You don't have to worry about this thing where the port has to go from learning mode to forwarding mode, etc. No,
Okay, thank you.
That's interesting because usually I mostly get people who are not familiar with that part, so it's like, okay, that's a switch. So you're actually, I think, the first person who noticed that thing and had clearly working experience with that kind of environment, and interesting. So yeah, containers get this an IP address on this internal switch. You can tweak a bunch of things here, like if you don't want the bridge to be called Docker 0, you can change that. If you want to use another subnet, you can change that. If you want to use a subnet of public addresses because you have tons of public addresses, you can even do that. And if you already have a route that conflicts with that subnet here, then Docker is going to pick another one, which means that on different Docker installations, you might think like, oh, that's funny, your IP addresses, your container IP addresses are 172.17 something, but this person has something different and I have something different. This is just because Docker has a list of internal IP ranges, and it just tries to take the first one that doesn't conflict with stuff you already have. But if you have stuff that conflicts in creative ways because it's behind routers, etc., then it has no way to know, and then you might have to force that IP range. But most folks won't have to worry about that. Oh, and one thing I forgot to mention, but that the container has its own network namespace, which is lingo to say the container can have its own routing table, IP table rules, etc., etc. So if you want to do routers in containers or firewalls in containers, etc. You can. It's relatively straightforward. Then the null driver. That one is pretty easy to understand. I do docker run -net none -ti alpine, and then when I do ifconfig, I only have the loopback interface, and if I try to ping the outside world, it's going to say, well, the DNS resolution won't even work, and if I do that, network unreachable. So that's useful if you want to have containers that are isolated from the network for any reason, like you want to check that this thing doesn't phone home or etc. Then the host driver, that one is also extremely interesting. When you run a container with --net host, and then you do ifconfig, you see all the network interfaces of the host. And if you do something like netstat -ntlp, so that means show me all the TCP ports on which you're currently listening, we're going to see something on port 22 and port 80 and port 32768, and there is nothing of that in that container. I mean, I just created that container, it's empty. So what is that? This is because this container is reusing the network stack of the host. So all the operations that are network related are going to use the information of the host. The point of that, well, there are many examples. First, if you have performance constraints, you're like, well, I'm doing VoIP and I have tens of thousands of packets per second, or gaming, or I'm doing video streaming and I have like 4 10 gig interfaces that are constantly pushing traffic, and all this port mapping business, I think this is bad for performance. Fine, in that case, if you use docker run --net host, the path, the code path of traffic going into the container will be exactly the same as the one of traffic going into the host. There is no port mapping, no IP tables, no bridge, no nothing, and you get raw performance. Other creative scenarios where you can use that is, let's say you want to do an IDS, something that watches over traffic on the machine and tries to detect like intrusion patterns or things like that. Then you can run that in a container, but you can still give the container access to the network interfaces of the host. Or if you know something like NTOP, which lets you have like a graphing, it lets you graph like packet counters, etc. on your network, you can run that thing in a container, but still have it access the network information of the host. And now the one that usually is the most like what is the container network driver. So I'm going to pick, I'm going to go back to my Docker host first, and I'm going to pick a container almost at random. Let's say this Nginx container, and I'm going to do docker run -ti -net container : and then I put the ID of a container, so the ID of my Nginx container, and I'm running Alpine. I'm in my Alpine container, nothing else is running. If I do ifconfig, I have an IP address. Okay, so at first it looks like everything is fine, but if I do netstat -ntlp, I see that there is something on port 80, and that's weird. So maybe we could curl it. Well, curl is not available in the default Alpine image, but installing it is as easy as apk update, and then apk add curl, and then I curl localhost, and I get the Nginx hello page. So this is a container that is sharing the network stack of another container.